Hey everyone, this is the second activity in the digestive system that we did in class. This is gastric emptying. So, again, when you're studying the digestive system, not only studying each organ and what the function of each organ is and how it does that, but I want you to understand the control of those organ systems. So in this activity, it goes over gastric emptying. So gastric refers to the stomach. And so basically what we want to know is, how does the stomach know, and I put that in quotes, right, when to release the chyme into the duodenum? Okay, you can look at table 16.2 in the textbook, and that's page 580. So again, how does it? So the point here, how does it know? It means what triggers does it use to release that content in the stomach, the chyme? So as remember, in the stomach, it's digesting food, digesting proteins using a very powerful enzyme as well as an acid, right? It's a pH of 2 in there. And so what we need to know is, so in the mouth, when we release food, we did that through pressure sensors, right? We could feel the consistency in our mouth, and then we voluntarily start swallowing. You lift your tongue up, right? And that pushes the food bolus up against the roof of your mouth, and then the swallowing starts to happen. Again, watch the lecture video so you can see that reflex on how swallowing occurs. But it started as a voluntary reaction in your stomach. How does your stomach then be able to determine when it's time to release that chyme into the duodenum? And well, this is how, right? So there's mainly these factors are going to be controlled in the duodenum, but it will be starting out within the stomach, of course. And so I just want to tell you a few things. One thing to remember: in the stomach, you've got that peristalsis. The end of the stomach is called the antrum, and those peristaltic waves of contraction get really strong. Okay, and that's what drives the emptying. But remember that the end of the stomach is closed by the pyloric sphincter. And so I'm kind of holding as opposed to being open, it's a band of muscle that pinches off and closes like this, right? So, factors that influence excitability by slightly depolarizing or hyperpolarizing the gastric smooth muscle, right? So the greater excitability that occurs, the more frequently that basal electrical rhythm, remember that was started, that oscillating rhythm from the pacemaker cells, the more frequently they generate action potentials, meaning they reach threshold. That causes a greater strength of the antral peristalsis, and then a faster rate of gastric emptying. Okay, so let's go with the table here. So it's going to start again, factors within the stomach. The first thing is the volume of chyme. Okay, so the stomach will um, empty at a rate that's proportional to the volume of chyme. How does the stomach know how much chyme is in there? Remember that it will start to get distended. So as the food stuff gets broken down and it becomes more liquidy, that causes those folds inside the stomach called the rugae to flatten out a little bit. So it's that distension has a direct effect on the gastric smooth muscle excitability, like I just explained. Okay, and so that's all part of that intrinsic plexus. The vagus nerve from the autonomic system, right? The parasympathetic system can also might start to um, send more rapid firing. Okay, and and we might see a hormone, and we'll talk about the hormone a little bit later. So again, basically the effects are, there's an increase in volume of chyme, and that stimulates the motility and the emptying. Okay, that's the effects here. Okay, the increase in volume of chyme actually does that. So again, just kind of think about that in generally. The more that the food is broken down, right, the more liquidy it becomes in the stomach. Okay, because of the hydrochloric acid and the other secretions and things. So as that volume increases, that's a signal that the stomach's going to start to release it. That's what's actually causing the smooth muscle to have more frequent action potentials, which is going to start to push it more. Okay, the next one is the degree of fluidity. Okay, the contents must be in a fluid form to be evacuated. Okay, so this thick, it goes from like the chunks of food that you ate that fell down into your stomach into more of a thick liquid, and it's got some chunks in there. It went from the chunks to this more of a thick liquid. So that degree of fluidity is what also causes then not only the stronger contractions of the antrum, then when it hits that pyloric sphincter, it causes it to open, boop, just a little bit, and then it closes again, because we're not going to empty all of the contents of the stomach into the duodenum. We're just going to do little bits of it, little squirts. Okay, and the reason is because, remember, this is mixed with hydrochloric acid. So we don't, and the duodenum doesn't have quite the same protections that the stomach does. So we're just going to do a little bit, but that's going to influence the next segment here. Okay. Factors within the duodenum, what's happening there? So remember, first there's nothing in there. Then because we got a little bit of chyme coming through, because in the stomach reacted to the volume of chyme and the degree of the fluidity of the chyme, it squirted some in the duodenum. And so once the duodenum receives it, now all of a sudden it's got the presence of fat, acid, right? And so that's another thing that controls that pyloric sphincter. As the duodenum senses fats and acids, remember there's receptors in there, it causes that sphincter to close, because it's going to work on this stuff a little bit at a time. Again, you don't want a rush of chyme in there. You just want a little bit at a time. So as those receptors sense that, it causes the closing of that pyloric sphincter. Okay. So it says in your table in the book, initiates the enterogastric reflex. Okay. Hypertonicity. Remember that the chyme now has a lot of substances in it that have been broken down, right? Substances that are dissolved within this fluid chyme. Okay, that's a hypertonicity. It's more hypertonic in the duodenum now than it is in the cells lining the duodenum. So basically, that means water wants to move out of the cells into the lumen of the duodenum. And we don't want too much of that to happen. We would dehydrate those cells. So again, as the hypertonicity increases, there are receptors that can sense that. And when it senses that, that sends a signal to that pyloric sphincter, boop, close. Okay. The other one there is distension, right? That just means as fluid enters the duodenum, it presses on the walls of the duodenum, it distends. That's a signal that, oh, we got fluid in here, so let's stop emptying more. So again, that receptor will send that response to the pyloric sphincter and close it. Okay, so as now you saw in the previous table, the previous activity that you did, as we're working on the fats and the acids, right, and the hypertonicity, right, the fats will start to go down because the enzymes are working on it. The acid will start to get neutralized because the buffer is in there. The hypertonicity will start to go down because the enzymes are working on the rest of the foodstuffs. Okay, it becomes more liquidy, so there's less distension. So as those goes down, then the signal is taken off the pyloric sphincter to contract, so it actually gets it to open again, boop, and we let a little bit more in. Okay, so that's why I said most of the emptying from the stomach is actually controlled by the factors in the duodenum. It's mainly because of this. Okay? But we could have other things that are occurring here. Let's see. Yeah. Emotions. Oh, yeah, I have that on here. Your emotions can actually affect your digestion, the gastric emptying. So that's why it's under here outside of the digestive system. It's your emotion. So what we found is that emotions can act on the autonomic nerves, right? The extrinsic plexus, okay, that influence the degree of gastric smooth muscle excitability. And that can vary among people, but in general, sadness and fear can generally lead to a decrease in motility. Okay, so when you're sad or you're afraid, you have less motility in the stomach, so you get um, less emptying. Maybe you don't feel like eating, right? That's because it's not things aren't moving like they normally will. So you just don't feel like you want to eat. Okay, anger and aggression tend to increase motility. So if you're very angry or aggression, sometimes you have an upset stomach. It may be more in the duodenum. Okay, and so because that increases motility, and you're releasing a lot more of the acids in areas where you don't have that protection. Okay, so the other one, kind of similar, is intense pain. Intense pain tends to increase the sympathetic activity, so that decreases or inhibits the motility throughout the digestive tract, right? So in this one, intense pain inhibits motility. I guess you would write that over in this box. Oop, how come we can't see it? There we go. Write it over in this box. So it inhibits motility and emptying because of increased sympathetic activity right here. Okay. Okay. So again, make sure you really understand, how does gastric emptying occur? Does the digestive system control the release of that acid chyme out of the stomach into the duodenum? Okay. And we broke it up as factors within the stomach, factors within the duodenum, and factors outside of the digestive system. Thank you.